we set up this experiment with the idea of looking at nitrogen amounts and nitrogen sources to see influence on improving the growth and development of olive young trees. The idea is to try to have a good balanced root system and shoot system of these young plants. The experiment has a variety, Arbucina, which is very common, tested here in Texas. We have a planting configuration of 12 feet between the lines and 10 feet between the plants in the row. And these plants have been subjected to basically two levels of nitrogen. We are using 20 kilograms per hectare and 40 kilograms per hectare versus the control. And we are using two sources of nitrogen. One is urea and the other is calcium nitrate. Urea is to provide basically ammonium sources of nitrogen, and then calcium nitrate providing a nitrate as a source of nitrogen. In addition, we have a control which is no nitrogen. So what you can see here is this is the regrowth of the second year, and the white tube is called as mini rhizotron. The idea of having this tube is to put basically a camera inside the tube so we can look at the root system and quantify root length density in the soil profile. From the first year that we conducted this experiment up to December of last year, we find out that it is critically important to determine the level of nitrogen, the particular nitrate levels in the soil before planting, what we call the pre-plant nitrogen level, because we are finding that basically the young olive trees do not require much nitrogen early in the development, especially if the pre-plant nitrogen level in the soil is in the sufficiency level. Here, when we planted this field, the level of nitrate in the soil were about 25 parts per million, which was more than sufficient for the young trees to grow. So it is important to know that there is really no need of applying nitrogen, whether urea, calcium nitrate or ammonium nitrate, when you have those levels. So there was no actual difference between the control plants with no nitrogen as compared to calcium nitrate or urea at 20 or 40 or 60 kilograms per hectare. So this is an important finding, because we also are seeing that at high levels of nitrogen, whether you use urea or calcium nitrate, the plants do not grow well.